Hey guys, here we are again. Monday, April 20th. All right, hopefully you guys are hunkering down and hopefully we're getting back ready to get back to school next week, but we'll just wait and see on that. I don't know. So we will get started on lesson 7.6. Similarity transformations, page 511. So let's look at page 511 and just read some definitions to start with and see where we're at. Transformation is an operation that maps an original figure, the preimage, onto a figure called the image. Okay, when we dilate it, that means we make it bigger, make it smaller. When your pupils dilate, you put something in your eyes, they put something in, they expand, they dilate, they get bigger. So a dilation is a transformation that enlarges or reduces the original figure proportionately. Since a dilation produces a similar figure, so when it dilates, it makes it similar. A dilation is a type of similarity transformation. Dilations are performed with respect to a fixed point called the center of dilation. The scale factor of a dilation describes the extent of the dilation. The scale factor is the ratio of the length on the image, okay, length of the image to a corresponding length on the preimage. So we can take a look at the figure in the book just to show you what this might be. An enlargement, okay, the enlargement would go from a smaller figure to a bigger figure, right? And a reduction is going to go from a bigger figure to a smaller figure, corresponding sides, okay? And they're going to be proportional. So each one of those sides is going to be proportional. So we have a reduction and we have a enlargement. The enlargement's always going to be greater than 1. This is always going to be greater than 1. And this is always going to be 0 to 1. So for instance, if this was 5 and this is 10, the enlargement is 2. Okay? The enlargement is 2. And if we go here, okay, if this was 7 and this is 4, okay, to find what that reduction is, you take the change of those, okay, you take the change of those and you put it over the original, okay? So that would be the change. It goes down 3, okay? And we start with 7, okay? 3 over 7 would be about 42, okay? About 42% reduction is what it would be, okay? So we take the change. This number, when we reduce it, is always going to be from 0 to 1. When we enlarge it, it's going to be greater than 1. Okay? Going to be greater than 1. All right? So, turning the page from 511 to 512, in example 1, we identify a dilation and find its scale factor, right? So we're just looking at what those distances are. Okay? We're looking at how big they are, and we're comparing them in terms of what it goes to. So here our enlargement goes from 5 to 10, okay, 5 to 10. Here we go down from 7 to 4 in terms of what those proportions are. Now each side needs to be the same proportion. If it's not the same proportion, then it's not going to be it's not going to be an actual similarity transformation. Okay, it will have changed, but it won't be similar. So taking a look at a guided practice 1A and 1B, we start with the blue figure. So we're starting with the blue figure. And when we look at the assignment you're going to get, always start with the blue figure. Blue figure is going to be your pre-image, and the green is going to be your image, what it's going to either enlarge to or reduce to. All right? So look at each side. Okay, when we look at guided practice 1A, start with the blue and then end with the green. Okay, so for instance, if we have, start here and this is 6, and this is 2, okay, we reduce it down, and that's 1/3. Okay, that's 1/3 in terms of what that reduction would be on that. Okay, take a look at 513, example 3, where we verify that it is a similarity transformation, that it is a reduction or an enlargement. We actually have to use, we're looking at coordinate geometry on example 4. And when we do that, right, we're going to either use the distance formula or we can use our Pythagorean theorem. Remember how we use our Pythagorean theorem right over here. So if we have a figure here, right, and we're trying to, let's make it a little bit bigger here, right? We're trying to find our distance from here to here. We can use our Pythagorean theorem to find this distance, right? This is 3, 2, 4, 6, 8, 9, right? This is going to be the hypotenuse. So we have 3 squared plus 9 squared is going to equal this distance squared. C squared, so we have 9 plus 81 equals C squared. 90 equals C squared. So this would be the square root of 90 equals C, or 3 root 10. Remember, we break square root of 90 down to square root of 9, square root of 10. Square root of 9 is going to be 3, square root of 10. Okay, so on example 4, you're going to look at proving and verifying the similarity. And so you have to prove it using each side. Prove each side that it's the same length, which would mean it would be proportional as well. So looking at our similarity transformations, again, we're dealing with proportions. Sides are proportionate of similar figures, and just got to work those ratios together. And again, use the Pythagorean theorem when we're talking about coordinate geometry here, or we can use the distance formula. There. So that's it for today on the similarity transformation. Have at it. I am available this afternoon and tomorrow. If you have any questions on that, let me know. And I'm out.